Compound inequalities. Let's get it. What is a compound inequality? What are the types of compound inequalities? An inequality that's made up of two linear inequalities. And we have two distinct ones. We have an AND inequality, x is greater than 2, and x is less than 9. So we're using the AND there, or inequalities. And we'll get into some examples here in just a moment. And inequalities. Inequalities where both parts can be true at the same time, but they can be written in two ways. We have this one on the left where you see the word and, x is greater than -5 and x is less than 3. Can we think of an example where that would be the case? How about the number 1? Is 1 greater than -5? Yes. Is 1 less than 3? Okay, that is an example of one that would work for an AND inequality. Same thing here. It can be written with the x in the middle. It's the same thing. X is greater than -5, x is less than 3. If it's written like this, that will be an AND inequality. And if we were to put that on the number line, let's see here. X is greater than -5. We've already marked that 1 works for both of them, so I'm just going to put a little mark there for myself as a reminder. They're always shaded between the two endpoints, so there's 3. This is an open circle because x cannot be 3 or -5. It has to be in between them. So your shading will look like this. Yeah, that's an AND inequality. Inequalities where only one of the two parts can be true at a time. This is only written in one way. You'll see the word or. X is less than -7, x is greater than 6. So the areas shaded are on the outside. Alright, so many examples. More easier thing to say would be an example of what could not be in there. Let's start with -7. It's not or equals to, so x is less than -7. Okay, so we got a circle around -7. Let's just get an example here. How about -10? -10 is less than -7, so I know this is going to go this way forever and ever. X is greater than 6. Okay, open circle here, and then we'll just keep the 10 train going. 10, yeah, that works. Alright, so the shaded area is outside of the two endpoints here. Make sure that your circles are either open or closed depending on what needs to happen. Alright, let's look at some examples for how to solve these. Clear this. Solve and graph. Okay, we've got a lot to do here. What should we do first? Well, how to solve a compound inequality. We've got to separate it into two inequalities and then solve each one separately. Graph the inequality on the same number line. The only ones that can ever be written quite like this are AND inequalities. We know this is going to be an AND inequality. So the first thing I do is separate this inequality. We don't separate it down the middle. It's not like it's getting separated right here. We have to take everything inside the first inequality. On the left, move it here. Trying to isolate the variable just like you would a multi-step equation. Subtract 2 from both sides. We're going to get 15 is greater than 3x. Divide both sides by the number 3. It's a positive number. We don't have to do anything special. 5 is greater than x. X is less than 5. Okay. Now, second thing we need to do, split the next inequality here. So we're going to have 3x plus 2 is greater than or equal to -22. Same thing, we start by subtracting 2 from both sides, leaving us with 3x is greater than -24. Dividing both by 3, we should get x is greater than or equal to -8. At this point, we probably feel pretty comfortable with what's going on. Let's start with our endpoints. X is less than 5. So we're going to go 5 on the number line. That is an open circle as best as you can. And x is greater than or equal to -8. This can be -8 because it can be equal to, so I'm going to try and shade that in as clearly as possible. This is an AND inequality, so it's going to be shaded in between, but just to be sure, let's look at point 0. Is 0 less than 5? Yes, it is. I'm not going to do that for both all of them. Is 0 greater than -8? Yes, it is. So I feel even more confident after checking that this is my shaded area, and that is how I graph this compound inequality. Let's look at another example. You can see the word or there. So this is probably going to be an or inequality. It's definitely going to be an or inequality. Not sure why I said probably. So they're already split. First thing I do, -2x plus 8 is greater than 0. I'm going to subtract 8 from both sides, leaving me with -2x is greater than -8. Divide both sides by -2. Oh, dividing an inequality by a negative means I have to flip my symbol. So x is less than 4. Going back up here, it's also starting with subtracting 8 from both sides, leaving me with -20 is greater than or equal to -2x. Dividing both sides by -2, ding ding ding, gotta flip my symbol, and I should get x is greater than or equal to 10. Alright, let's go down to the graph. Let's mark our endpoints. 4 is going to be an open circle, there's no equal sign, and then 10 is going to be a closed circle. All right, so let's look at an example here. Is 8 less than 4? No. We know this is an or inequality. It's still good to check. 0 is less than 4. Is 12 greater than or equal to 10? It is. So we're going to graph it like this. Those are compound inequalities. Let's get some practice in.